Hi, John McElroy here from Autoline at the Caresoft facilities with Terry Woychowski, the president of Caresoft that does all kinds of competitive teardowns, and we've done a number of videos before. Today we get to see the Cybertruck battery pack.
Yeah, we're at the heart and soul of the truck here.
And thanks for inviting us back, Terry. Really appreciate it.
Pleasure, I appreciate it. And I'm glad you could kind of join us as we've been on this journey of tearing this down. We'd like it to go faster, but we do engineering work. And so along the way, we have to make measurements and calculations, and that's why there's some time involved with this entire teardown process. We're not just ripping it apart and taking a look at it. We're actually trying to understand it. And today, I'd like to show you the battery. This is pretty much the heart and soul of this thing. John, here at Caresoft, we do a couple things. First, before we have a battery, we discharge them. So we've built our own discharge units. And so we discharge the battery and drain all the power out of it that we can. And then you'd see a shunting wire. So this wire is actually our wire. And so we shunt across the battery. This keeps the battery from regrowing a charge. Just let they just sit there, they can reaccumulate some charge. So we discharge it, we shunt it so it doesn't go, and then we treat it as if it's full. And
very carefully.
And with that combination, it's been a good, successful approach to these batteries, because there's a lot of risk in these batteries.
Well, this thing's huge. I mean, huge. This is like a king-size bed practically.
Yes. Yeah, about 1,600 pounds worth of batteries here on that truck. So. This is we'll start here. This is the top. The front of the vehicle's over here. And this is the part of the battery that would be facing upward. We happen to have it in this rotisserie to help us maneuver it and do some work with it. But this piece of the battery, this is the brain center. This is the Penthouse. So this is where all the decisions are made as what to do with these batteries. Okay. So I'll kind of walk you through those, and the best I can. We got more experts here and can give you a lot more in-depth detail of this. But basically, we charge the battery, and we do it from a power source. And so this is Tesla has a unique approach when they from a charging perspective. Typically, these harnesses would be made of copper, and they would be flexible, and it would be a little bit like wrestling an anaconda. They are heavy, and they are tough to negotiate. But Tesla's made theirs out of aluminum, so it's actually an aluminum conductive rod. There's an insulator over it, and then there's a protective sleeve, aluminum sleeve over that, and then a coating here, just from a standard perspective, so don't cut here. This is the high end.
Don't cut here in case EMS has got to get into the vehicle.
First responders, extrication, and that type of thing. So if you see this orange stuff, best not to cut.
Don't touch it.
Yeah, don't cut it. This mounts here. Mm-hmm. Now, because it's a solid part, it can even be automated. I mean, it really is a pretty good way to attach these. But the power then comes into the battery through these large terminals here. So power is coming in, and then it's going through a variety of controls here. This control, this is our battery management system, that
this
black
whole
piece. Yep.
Piece here.
And that's really making a lot of decisions. So when the power comes in, look, what kind of power is this? What have you fed me? You fed me 110 AC, 220, 400. 800, fast charge, all these different things. And so it determines that right away. What kind of charge is this, and what should I do with that? Up to including nothing, to, okay, this is what it is, and so what we're going to do with it. If it's an AC current, because you plugged it into your house, it's going to go through a converter, an AC to DC conversion, and then it's going to take that power now and send that into the battery cells to charge them. So it'll do that AC to DC conversion. If it's a 400 volt coming in, there are contactors that are located just below here. And so the battery management system will tell it and say, close. Mm-hmm. And it'll tell the appropriate contactors to close, and it'll send the power. So if it's 400 volts, this is an 800 volt battery. Mm-hmm. So if it's 400, because you're on a 400 volt charging station, it says, oh, okay, it's 400. I have two 400-volt batteries. And so I'll charge them both in parallel, and we'll build up that charge. If it's 800, it says, oh, fantastic, those different contactors, and says, it's 800 volts, give me the 800, and I'll charge all these things in series. So it's making all those decisions pretty much in real time and sending the power the appropriate places. You can see a tap. This is one of the terminals. There are 4 major channels of battery cells here, so it's almost like 4 packs. And there's one connector, another one, another one, another one. So there's 200 volts, 200, 200, and 200. You go across here to here, you'd measure 800 volts. That'd be end to end of the whole pack. Also, we have the ability then to take this power and to bring it back through an AC junction box and send it out of the vehicle as 110 or 220 AC.
So power tools on the job,
Power
kind of, or any
tools.
kind of power that you might
Charge
need.
another vehicle. Yeah, so you want to tap. So we'll take the battery we just charged and we can bring it out, change it to AC, send it out, and then to use that. Also, coolant comes in because these things run hot, as you can imagine. There's a lot of current through here, and so we have to manage the temperature. So coolant will enter the bottom of the Penthouse, and then it will circulate through all these.
Is it a
components.
liquid cooling?
Yeah.
And so are all these contacts in contact with liquid or no?
Not the contacts, but
Okay.
these.
It's
these
channeled
systems here.
inside of all this stuff.
Now the battery management system is managing the battery. It's the boss. It's looking at everything. It says, okay, how are my cells? What's the temperatures? What's the current? And so it's balancing those. It's making sure one isn't hot. If something is going amiss someplace, it says, oops, take a time out, and we'll shut this down. So it's understanding the state of charge, and it is telling you a calculated state of charge. Unlike a gas tank where you know full, empty, because of a float, it's a mechanical measurement. Measuring how much voltage do I have in this thing, how it charges it, it's a matter of calculations. So battery management system is doing all that calculation, saying you have 300 miles of range or whatever you may have. So a lot going on. Different from the Model Y, we see application of a lot more fuses. So I don't know if that was lessons learned along the way or because this is an 800 volt beast. I think a lot of this comes down to the fact that this water wading mode, this boat mode, I think that was a bear. I think that was really bad. Really difficult challenge engineering-wise. So now we have more protection, more fuses. In fact, this fuse, it's in a gummy kind of a potting. It's actually kind of sticky.
Oh yeah.
Yeah, that's for the AC
That's
compressor.
weird. I mean,
Yeah.
it's like glue
It's like
almost.
glue, like undried glue. Also, you notice that there's this interesting potting material that has come around.
It looks
a
like
lot of that.
putty.
It looks like putty. I think kind of is like putty.
Yeah.
And I wouldn't be at all surprised if that didn't come in late in production because they said, oh, we've got some water intrusion, we have some problems. There are actually 4 water drains in this Penthouse. So if water does enter that, we've got in the 4 corners, there are drains, and the way they're made is that when they're exposed to water, they swell, they change, and they pop this open, and it lets water out.
Huh. Let's get that for the camera view too.
So the Penthouse has 4 of these in. You see this, which may have been evidence that they had some water intrusion. And then interesting, when you look at the top of the battery box.
This is the top of the Penthouse.
The top of the Penthouse. We see this insulating material over here.
This yellowish orange stuff.
And that's like, well, why is that there? Well, I don't know, other than I can speculate. There was some sparking going on. There was some witness that water was in there.
Hey, and another thing, this is just, an aside, they've stamped the Tesla logo into this. This is aluminum, I'm taking?
Yeah.
Yeah.
There's also in the box this DC to DC converter, in that you can think of this as the alternator in your car. You know, with this new 48 volt architecture, there isn't an alternator that's generating 48 volts and keeping that battery charged. This battery is keeping that battery charged. And so the actual 48 volts is occurring right here. We're pulling that off the battery and sending that out. So the onboard 48 volt battery, that's for startup and some systems, but the actual draw of 48 volts is going to be coming right through here, right off the main battery.
Very interesting.
Yeah.
Okay. What else, Terry? I know you
So,
got more here.
Well, you can see the structure here. There are large cross-car structural beams in this battery. With a battery electric vehicle, side barrier becomes really critical. Front barrier, we've got all that frunk. We've got all that metal to crush and dissipate our kinetic energy, deform metal, heat and light, get that energy converted. With the side pole, your battery is essentially there. And so what we do is we take a lot of that load in through these, actually transfer it across the car, even into the other rocker to try to diminish. So side pole becomes really pretty hard and difficult.
And when you say side pole, I mean they literally smash the side of a car into a pole.
Bang it right into
like
the
something
side.
sunk into cement kind of a pole.
You bet. Yeah, well, it's an unmovable pole. Yeah. And you can't have displacement of those cells. You can't have them shorting out. You can't have them, causing electrical problems.
So this
inside
just
the
gives
vehicle.
more strength for side
Yes,
impact.
exactly. Also, it serves as a means to mount the seats. When Tesla launched the first Model Y, the seat structure was a stamping, like most seat structures. So this gets bolted to the floor, and then the seats get bolted to those structures.
This thing here you're
That
talking
thing.
about. This
Yep. That was inboard with the console, and then the outboard pieces.
a lot of stamping, a
next
lot
to
of welding, a lot of little pieces
Right.
to all this.
Then in 2021, and I say that a little tongue-in-cheek because model year and Tesla don't exactly go together, but this is when at the Model Y, the floor disappeared in the body in white, and the top of the battery became the floor of the car. And then they mounted the seat directly to the top of the battery. So they did it in this fashion, to get more integration, more efficiency. And so these seats are attached to this battery. When it comes in place,
Yeah.
seats are gone.
Real smart move. It really simplifies assembly.
Now, with the Cybertruck, taking it another step, so this progression that we're always seeing, there's some evolution in Tesla. Now that structure is a casting.
Very interesting. So one piece,
One piece.
not all these stampings, not all this welding.
One piece.
I mean,
And
this company loves castings.
Yeah. And it'll just come over, and it will locate. It's got a locating pin, and so it will locate, and then these holes will be lined up, and you can just drive these fasteners in.
Right in. Yeah.
So it's all that's gone, all those multiple pieces and all that. So this casting is continually evolving to new and more places. And when we get to the body in white, you'll see it
Okay.
quite a bit. With that, that's pretty much the Penthouse. Keep water out of it. Now to do that, when you're in this waiting mode, so you go to the HMI screen and you go to waiting, or I think Elon even called it a boat mode. A couple interesting things. One, it takes a half hour for the vehicle to be prepared.
Really?
So if you want to wade through a stream, it's a half hour. And the reason is because that big air cylinder that's used for the suspension, it's going to charge this with air.
Pressurize the
It's
inside of
going
the
to
battery
pressurize the
pack
battery and the Penthouse.
so that water can't get in because the air pressure will hold it out.
If the pressure is greater than the pressure coming in, the air is going out.
But yikes, a half hour. You better plan ahead.
You better plan ahead. It takes a half hour to get it, and then I think you're allowed like about 15 to 20 minutes in the water. And you can't go above the bumper and some other things, but it's like you better get in and have your fun and get out because remember Isaiah Thomas when he was in a Piston? He used to run some public service announcements that said water and electricity don't work, don't mix. They don't, and he was right. If we come over to this side, which is the bottom of the battery, it's not overly impressive when you see it, other than being large as a king-size bed. But there's a couple things that you see right away is it's extremely structurally tough. This piece that runs down the center appears to simply be a means of holding it in the manufacturing process.
I was going to ask you that because it almost looks like you could bolt seats or something to that.
No, you can't. This is the bottom.
So it's just for
It
in manufacturing
hooks to
location.
because the last thing you want is this falling off on your factory floor someplace.
Yeah.
So that's being held.
But this is a stamping with weldings too.
You bet. And you can see there's 4 channels. We'll see those filled with batteries in a minute. But each one of them constitutes a channel. And what you'll notice is there is a vent at the end of each one.
Oh, interesting. These 4 orange
Those
blocks.
4. So in the event of an overpressure, if there's a thermal event, something that's very hot and you start getting a pressure buildup of gas, this will blow out. Poof. It's a one and done, blown out.
Yeah.
You're done, go get it repaired. But you can see where those come in. And then the structure where you're starting to bolt this to the body structure. You have body drop, so a lot of bolts around the perimeter and a lot of strength here and again for that side pull. So with that, I'll ask the guys to take the battery cover off. We can kind of see the business end here. By the way, before they do, we were talking about the water drains.
Yeah.
They're also here.
Oh, interesting.
Here. Each quarter, they have those types of, they have a combination of those valves that look like this. They work essentially the same way, and some smaller ones here. And
So if they detect water, they open to drain it?
when they get exposed to water,
Okay.
they swell and they change the shape here and it pops
Interesting.
up and then it blows out. And then these are covered with a little piece of plastic once they're in place. So get water out of there.
Yeah,
Part of the-
like I
the
said,
key.
water and electricity don't mix.
Yeah, that's right. Derek, would you?
And now the dramatic moment.
Yeah. I usually lift this myself, but
Sure you do.
today.
Wow.
And that's it.
So these are all the cylindrical cells that we see behind
are
here, I'm
all
guessing?
the
So
cells.
what is all this greenish, almost, what is this, foam or something?
Well,
Or
there's a couple different
plastic?
kinds. There's like an injected foam here. This looks similar to what was in earlier Model Ys. And you can see where it's been injected to close up spaces, to give it structure, and also from a sealing perspective, where it's sealing off these different parts. This is a membrane, just a thin membrane that's covering this mica. So again, I think just from moisture and water, and
Just to seal it,
trying
huh?
trying to protect this.
Wow, that is so, and what's this foam stuff?
It's a mica here. This injected foam, you mean?
Yeah.
Yeah, that's the foam.
Just to keep the cells all separate
Right.
and everything?
Now in the Model Y, they'd gone to, for a little while, they'd gone to this type of a foam, which they used to inject into the cells, which is almost impossible to get off. Really a challenge. But this is essentially what one of these cells look like.
Wow.
4860. And you can see there's a bunch of them.
Yeah.
So when they get put in, they get set in place, and then 6 pins come in, these injectors, and they inject that plastic in here. Okay.
And I'm guessing this
so-
plastic or this foam
Yeah,
is
it's foam.
non-flammable.
Well, this stuff is.
Oh, it is?
I would thought the same thing. Well, it must be from a thermal perspective.
Yeah.
Take a torch to this, it goes up pretty good. So it's like, no, it's not doing that. But this is a little bit different material, so we'll be doing some flammability work on it to get that
Yeah.
observation. One of the things that they had to do, because the Cybertruck doesn't have a floor, just like the Model Y doesn't have a floor. And when they did that, the first batteries that they made, the vent, if this gets hot, it needs to outgas. You don't want to build up pressure inside that cell. Bad things would happen. So in the event that it gets too hot, it will outgas. But when they took the floor away, they actually had to move the vent from this side to this side, so that when it vents down. Because the last thing you want this thing is vented up to
into the cabin,
into
right.
the cabin, which is because it's not a floor.
Let's show that here. the vent right in the center of the bottom of the battery. Interesting.
Yeah. You can see the batteries are aligned in these 4 chambers. About 200 volts a piece here. You add them all up, we get 800 volts. Coolant comes in and then runs between all these cells. And so it snakes between them, cooling all those individual cells, and then exits the vehicle. If you look down on this end at the bottom actually of the Penthouse, this is where the power then comes out of the battery and goes to the front motors, the front e-drive. So out of the battery to the front motor, spin it, and we're moving. This is a dream. This is the range extender. And so there's been talk about, hey, if you want more range on your Cybertruck, we're going to give you another battery, auxiliary battery, that will mount inside the pickup box.
Almost looks like a toolbox in the back of the bed, right?
And if that comes to be, when it comes to be, this is where it would attach. So it's engineered for it, it's ready for it. Now when that box will be ready would be up to Tesla, but if it does, then cabling would go from that auxiliary box, pass through the floor and connect here. Just like we had the front e-drive, we have the rear e-drive, so we're sending power to both. This is the connector just for the AC compressor. I don't know if you've ever tried to turn an AC compressor by hand, but it takes a lot of power, and so we send that out. And there's also been talk about an inductive charger that Tesla has been teasing. We're going to come forward with an inductive charger, a mat. You simply drive over. There's probably some targeting in your HMI screen, and I'm right over it, stop. And then inductively it'll charge. If you were to get that, a device would plug in here. So this would be able to...
So they've obviously planned ahead.
It's planned, this is planned, it's there, this is planned, it's there. When the other piece comes together would depend on their engineering validation.
Smart. And I'm guessing, what's this? Is that the air pressure tube?
That is. This is a manifold from that air cylinder we talked about last time. It gets plumbed in. It charges the Penthouse and pressurizes it. Again, we have the
blow-off
water
valve,
vents
so
here.
to speak. Yeah.
And then the pressure comes out and comes around down into here and pressurizes this whole thing. That's why it takes a half hour to get ready. There's a lot of
That's a lot to fill
lot
up.
to fill up. So that's all filled, and then of course it's trying to keep water from ingress. You can see it has to be sealed for all these eventualities. Also, you'll notice this is the side. We were talking about side pole. There's a big cavity here on both
Crush
sides.
space?
Crush space. That's so we
All-
can...
all the space
all
right in
that
here,
space.
yeah.
So you can take all that deflection, and there's a beam inside the body in white. It's going to take some of that load, and then we're going to dissipate it here before we get into all the structure on the battery.
So
to try
it would
to move
take a
to it.
hell of an impact to get into the battery.
It's designed to do that.
Yeah.
Because the last thing you want is these things to start to deform, crush, tip. That's why these are being injected like this. It keeps them structurally isolated from each other and standing, so they don't get tipped over, don't get hot, those types of things. We'll also see a considerable depth. It's like, what is all this space? There's a lot of wasted space here. It could, because that cover, comes right to here, so we've got this entire dimension.
So what do you think this gap here is for?
I think a couple of things would come to mind. Number one, if it's an off-road vehicle, and if you high center this thing and you come on a rock and you bang it, the last thing you want to do is either puncture or bend that plate and come in here and kiss these batteries. That would be a bad thing. So you've got that duty cycle, and I think there's a reason those water vents are there. And just you're giving some room, some headroom here for some water. So water comes up, pops off, and then we would drain the water. Now, unfortunately, because of the design, the vent isn't right at the bottom. It is below this, but you'd have to slosh some of the water to get it out of there. It's still going to have some pent-up water. You don't want to get water in there. There's also seals between each of these channels. So these seals come in to keep these things independent.
A lot of thinking, a lot of engineering that's gone into all this.
It's remarkable, actually, when you look at everything that it is and everything that it does, and the duty cycles that this one in particular is going through. There's a ton of engineering that's gone into this.
Have we covered it?
I believe we have. The cooling that we talked about for the battery, cooling comes in here and circulates through all and comes out. And then you see how all this is potted to protect it all. So with that, you should have enough power to get you up and down the road and up and down across the rocks, I guess.
You should. Terry, thanks so much, man.
John,
I
my
really
pleasure.
appreciate your
My
insights
pleasure.
and everything that you guys do here at Caresoft to help us understand more of what's going on in the
You're
Cybertruck.
welcome. My pleasure. Thank you.